I can feel it. I can feel it. It's going to work this time. It's going to work. It's going to work. Oh, these painstaking notes I've created over the years. I tell you it's going to work this time. I can feel it. I can feel it. I can feel it. Just need a couple of more little dissections here. A couple of sparks there. I know I'm missing something. Come on. Work! Work, I tell you. What am I going to do? Yes, I did it! I did it! It's working! It's working! Yes, yes, yes! Ha ha!
Madness comes in waves sometimes. Can be influenced by dreams or memories. Forget what's real and what's not. Sometimes you even forget yourself. When you're lost into this abyss by yourself, it becomes hard to realize how much you're missing, how much the world was to you. Projections are aggressive. The mind is dangerous. You won't know what's true, and you will lose yourself. It's just a part of nature. I was sent in. I was supposed to just examine the environment. Things changed. I don't know if it was intentional or not, but things did change. Hopefully, I'll get out.
Frederic, welcome, Conrad, welcome.
You said you wanted to see me, Mr. Blackwell?
Yes, I did want to see you, Frederic. Now, I know what you're thinking. What if I got going on? Don't pay attention to this right now. Everything is okay. Okay? Now, what about that right now? It's important. He's okay. He's okay. I promise you. So I have my machine that's finally working. It's working. I've got it working. The only problem is that our good friend Christoph over here, he is still under. Now look, he's not dead. He's totally fine. But the only problem is he won't go to the light. He's been there for about 8 hours or so.
8 hours?
He's fine. He's totally fine. I promise you, he's fine. He's okay. Take me. I'm a doctor, okay? Look, I even got the paperwork and everything to prove it.
You're a high school teacher.
No. Yeah, that's a front. I can make money on the side. They don't pay me enough. But look, just come over here to me. Come over here. I got something I need to talk to you about. It's gonna be fine. Don't worry about it. Come on, you can trust me. I'm a doctor. My name's Black. Okay? You got it. Everything's gonna be okay. Capiche?
All right, Mr. Blackwell.
So look here, Frederic, look here. Look what I've come up with. I created something I don't know. Baby got back. It's not working right now. There's something in there. He's been too long, and there's so many different levels that he's in. There's level 1, 2, and 3. But I know you're this great math prodigy, so I don't know exactly what I have, but I figure you could come up with something to help bring him back.
Well, it seems like this is Laha Patel's rule, and Laha Patel's rule is a method at evaluating limits. So if we learn how to solve this problem on all 3 levels, we might be able to save Chris and get him out of there.
Well, that sounds like a plan. I'm putting you in charge of it. Okay, I gotta go get me some coffee, okay?
I'm gonna need time to work this out.
So, Frederic, what you're about to do, you're gonna go in, okay, into the machine. You're gonna hook yourself up with this here right here. Make sure you plug in, okay? Because I'm not gonna be responsible if you get lost in there. It's all on you. You've already signed the waiver, okay? See? John Hancock's right there, somewhere. So what you're gonna do, you're gonna go in, you're gonna find him, you're gonna go to the different levels, put in the different equations, okay? And then that should bring him out, all right? And maybe I'll find a different little tune to how to kind of help you guide you on your way. I'll put in Baby got back. No, baby got back. It's not working. I'll put in my some Michael Jackson, Baby Be Mine. How about that? I'll put that in there to help bring you back. When you hear it, it's when you're getting closer. Okay, but make sure you climb to get through those levels and get them out. Okay.
Okay.
Head towards the light. Okay, and don't cross the streams.
Okay. I'm going in.
Baby got back. It's not working right now. There's something in there. He's been. No. But I know you're this great math project.
Like, this is Lahab Patal's room.
I like big butts and I cannot lie. You other brothers can't deny. Now when a girl walks in with an itty bitty waist and a round thing in your face, you get sprung. Wanna
Pay attention to what happens here. This world is different than the one prior. Everything's shattered. This is my world.
I've been here for 3 weeks. The world is starting to make less and less sense each day. These projections have become very violent and stare constantly. It's to the point where I don't even know what's real anymore. But after some time, I found clues that eventually led me to him. Christoph, is that you?
What are you? Projections aren't allowed here.
It's me, Frederic, not a projection.
What are you, Frederic?
It's me, your classmate, Frederic. Come on, please. You don't remember me?
It was a lifetime ago. You can't be the math. What do you call it? The math.
Math prodigy.
Prodigy. Yes. There's no other prodigy in here other than.
How long have you been here?
You don't know this place well, do you?
But I came to get you out of here.
This place is harsh, boy. Follow me. Have you ever seen my spinner? It keeps on spinning. I think it's broke. And I got my machine ready to go to that stream. Any questions?
How did we get here?
Don't worry about reality, my brother. Moving on.
There are principles, rules that work here and nowhere else. Once you learn these guidelines, reality
Can and will be understood.
these rules
I can teach them to you. There are loopholes, things that cannot be explained. Only in this world, my world.
can things be inconsistent. Clothes change, buildings bend, people not caring. It's all here, and I've been here.
Too long.
While you're here, make the most of this situation. Persevere.
Only then will you endure. You stand yourself, but you can learn to believe.
Now, do you understand?
No.
This world is so beautiful, and yet so dangerous.
You've been in here way too long.
But you want to go deeper.
Because that's how we're going to get out of here.
Are you sure?
Positive. At least, that's what Professor Blackwell told me.
All right, boy.
Where are we?
We went over this.
I mean, yeah, but this is different from every other dream we've been in. It's dark.
Well, my bed is gone again, so I'm guessing this is the third level.
It's different than I thought. Better watch yourself. It's extremely unstable here. The solution should be this way. You better hurry. This isn't normal. we get through this, I'm gonna teach you how to keep your clothes consistent, because they keep changing.
I gotta rob people.
The solution should be where it began.
Frederick, welcome. You finally made it. And look, you've got Christopher here with you. Good job, boys. What do you mean, Dixie? You got to, didn't you? You followed all the rules and everything. So now look, we're here. Let's go. Let's go. So glad you're here. Good to see you, boys.
It's been 6 months, Black.
Really?
You said 8 hours.
Yeah, there's some gray area in there. Some gray area. Some
Gray
small
area?
calculation. That's all. You're okay. Life is good on the outside, I tell you that much.
You would know that.
I would.
Speaking of the outside, why are you here?
I am just a projection of your subconscious. I'm not really here right now, but I am here. Or am I? But I'm not here. I'm not here. How would you want me to be? You believe that I am here, and I am here, but not really here. I'm on the outside.
That's enough of that. You said there's a solution here, so we can get out.
Of course there is. It's a solution. There's always a solution.
That's what you said the first time.
But I'm right this time. Because you found it, correct?
No, not yet.
Not yet.
I think we're close to solving.
Well, keep going, boys. You'll get it, okay? I promise you, you'll get it.
I think I saw.
You did?
You have a piece of paper?
Over there. It's over there. Your problem is over there. Your paper, the pencil, everything that you need is way over there, okay, boys? All right, go.
No more jokes.
No more jokes, I promise. Got some. Okay?
I got bad feelings about this.
For L'Hopital's rule, it's used for evaluating limits using derivatives. Only applies to plug and chug results in indeterminate, which is basically when you plug in limit of 0 into this right here, get 0 over 0. Or if this were infinity, get infinity over infinity, that would be indeterminate. It's not right in this form. We gotta do some work to actually get the actual limit. For infinity, you gotta remember, if there's infinity on the bottom and there's a constant up top, limit 0, bottom heavy is always gonna be 0. So for the first limit problem we got here, limit s goes to 0, we gotta have the derivative of the top and the bottom for L'Hopital's, but because when you plug in 0 to this as it is, you get 1 minus cosine 0 over 0 squared. Cosine 0 ends up being 1, 1 minus 1 is 0, 0 squared is just 0, 0 over 0, that won't work. So we use L'Hopital's. 1 minus cosine x turns into sine of x when you get the derivative. X squared turns into 2x when you get the derivative. Limit of x goes to 0 into sine of x, it ends up being 0 again. Limit of x going to 0 for 2x ends up being 0. So that still won't work. So we have to use L'Hopital's again. Sine of x turns to cosine of x, and 2x turns into 2 when you get the derivatives. Limit of x going to 0 for cosine x over 2 actually ends up being 1/2 because cosine of 0 is 1 and it's over 2, so 1/2. So we can put therefore limit of x going to 0 for 1 minus cosine of x over x squared is 1/2. That's the first problem. So for second problem, we got a limit of x going to e. So the limit doesn't have to always have a 0 or infinity right here in order for you to use L'Hopital's. As you see, we got e here, and when we plug the e into this problem, we end up getting e to the 20th power minus 3e, minus e to the 20th power minus 3e over e minus e, which ends up being 0 over 0, so we can't do this. We have to use L'Hopital's. And limit of x going to e for this problem, get the derivative of the top, you end up getting 20x to the 19th power minus 3 minus 0, because this right here is a constant. Constant always ends up being 0, and
E right here that we began with, this is a 0. So, and X turns to a 1. So, end up with 20e to 19 minus 3 ends up being the limit to this problem. And down here, we got delta X, limit of delta X going to 0. So, here's the problem. We got another constant right here, similar to this one up here. And when we have a constant, it always ends up being 0 when we get the derivative. So we get the derivative up top and up on the bottom. Derivative of delta S ends up being 1. Derivative of cosine of pi over 6 plus delta X ends up being negative sine of pi over 6 plus delta X. And that ends up turning to negative sine of pi over 6. And when you plug in the 0, and that ends up being negative 1/2 when you look at sine of negative sine of pi over 6. For justifications, when you write this out, don't put x over x equals 0. That's wrong. You have to show the top part equals 0, and you gotta show the bottom part equals 0 separately. And then you find the L'Hopital's, and then it turns into 1 for this problem right here, x over x. For the last part, we're doing limit to infinity for ln of e to 3x plus x all over x. Remember, when you get derivative of ln of x, it ends up being 1 over x. It's just interesting. Derivative, you have to remember this. So, limit of x going to infinity, ln of this mess turns into infinity when you plug in infinity each one. So, it's going to be infinity up top, and then we plug in to the bottom part, x. When you plug in infinity for x, it ends up being infinity. So, that won't work since we have infinity over infinity. This will not work either. It's about the same as having 0 to 0. So, for when we use L'Hopital's, we actually get this right here, because following ln of x going 1 over x, we put this at the bottom, and x just turns to 1, so we can just forget about the x when we find the derivative. So, it ends up being 1 over this mess times the derivative of anything inside the parentheses. Derivative of what's in the parentheses ends up being this. So, we end up having to find out what x going to infinity at the top is, and the bottom ends up being infinity over infinity again. So, L'Hopital's again. So, limit of x going to infinity of this mess, derivative of all this ends up being 9e to 3x over 3e to 3x plus 1. And do it one more time and plug in infinity into both of these, and they both end up being infinity again. So we do it L'Hopital's one more time, and we find out that this comes out at the end. And interesting enough, you got e to 3x for top and bottom, so they both can cancel out right here. And with 27 over 9, which equals 3. So we can write the limit out as the limit of x going to infinity for everything right here is 3.
Chris. Interesting. Yes. Looks like I learned something new for you two, eh? Good. It looks good. It looks real good. Interesting. Okay, Christoph. Looks like you boys did good. You boys did really good. It looks good for me and right here. So I guess you all know that you all may now go towards the light. It's yours. Go. do you mean?
You said we were only supposed to be there for a couple of hours. We were in there for months.
It's only been a couple of hours, I promise you. I
We
promise
saw
you.
the craziest things. Buildings were crumbling in front of each other. There were so many people that were just hostile towards me. They were staring.
Don't know what that's all about, but hey, you're back, so that's all that matters. So come on, let's go celebrate, you know, have some couple of shots, you know, maybe a little candy, hey, you know, let's go party. Where's Chris? Where did Chris go?
He stormed out of anger and madness.
Oh, so he drove him crazy, huh?
Yeah.
But at least I can say the machine worked, right?
No. I think I'm done with you for a little bit.
Come on, no, don't go. Don't go, we have so much fun. I've got more experience to test out. Come on, trust me, believe me.